Good morning and good evening, people of YouTube. My name is Johnny Bannon with Hsrp Technologies, and today we're going to be going over first hop redundancy protocols, specifically Hsrp version 1 and 2. So click that link below to go to our Confluence how-to page, and let's get started. Alright guys, so first things first, right? Click that link below and go to Hsrp Technologies Confluence how-to page. So here I've done a little write-up of what first hop redundancy protocols are and the 3 that Cisco supports. So today we'll be going over Hsrp, but just to get a little background on the information, all first hop redundancy protocols essentially have one goal in mind, is that's redundancy for your routers, right, on the WAN. So one way to create router redundancy in your network, right? FHRP protocols do this by sharing a virtual MAC and IP address to create a virtual router that all your LAN devices can connect to. So Hsrp and GLBP are Cisco proprietary, and the key difference here is that GLBP also offers load balancing, sometimes called load sharing, between a group of redundant routers. FHRP is the IEEE standard for an FHRP. They essentially all do the same thing, guys. With GLBP, you also get load balancing. But today we're going over Hsrp. So routers that are configured for Hsrp work together to present themselves to the network as one gateway. So what does this mean? In Hsrp, you have one active router, and you have one standby router. And they each share a virtual MAC address and a virtual IP address that the users on our LAN know about. So our users won't know that there's 2 routers, each with an individual MAC and IP address on their interfaces. All they'll know about is a virtual MAC and the virtual IP address that they use for their broadcast, to send their traffic, and for all their ARPs. So Hsrp uses multicast addresses and hellos to actually create, I don't know if you call it a neighborship, but to know about each other, right? So they use hello messages to communicate, and the multicast address for these hellos on version 2 is this one right here, 224.0.0.102. Then Hsrp's MAC address, only the last 3 hexadecimal digits will change, and those are represented by the standby group number. So in Hsrp, we can have up to 4,095 actual groups between routers. The Hsrp version 2 also supports authentication. And like other routing protocols, guys, it actually also goes through a learning state, you could call it. And here are the packets, right? So you have the initial learn and listen, and then your routers will either go standby or active, okay? So how these routers will choose which one's active and which one's passive, or standby, excuse me, is actually in how you configure it, the sequence, right? So if I configure R1 first and leave the priority at default, and then R2, R1 should be the one that becomes active. So today's how-to, we're just gonna configure and then verify basic Hsrp with preemption, set the priority, and authentication. So the key thing here of preemption, guys, is that if one router goes down, let's say this is our active, this is our standby. If this router has preemption enabled and it goes down, router 2 should take over, right? Now what if R1 comes back up? With that preemption configured, R1 should take over its active role again, okay? And then as far as priority goes, so that should be how these routers determine who's the active, who's the standby, but as we'll see in our configuration, we'll just configure router 1 and then router 2, leave the priorities default, and we'll see that the router we first configured actually becomes our active router. So first thing, right, we got to set up our network, or our GNS3 environment. So let's launch GNS3. Let's go to our projects library. I have it loaded already in here, guys. I don't believe I've saved any of these configurations, so if we go into router 1, 2, and the switch, it should be empty. So again, if you need some time, go ahead and take a look. So what you guys don't see in the background here is that I actually have this Confluence how-to up on my other screen. So I'm going to be using this Confluence how-to page while going through this lab. So if you have two monitors, my suggestion is to bring that how-to to one monitor, and then your GNS3 in the other. So let's get into these routers. It looks like there's nothing configured on them. I know this seems OCD, but I gotta have router 1 above. It's the first router, right? We gotta configure it first. All right. So according to our Confluence how-to page, first thing I'm gonna do is just some basic IP addressing. So we're gonna do that, but also give it a host name, and then do some basic housekeeping commands. Then we'll get into interface gig 00 and give it an IP address. So when doing Hsrp, right, we're going to actually configure it on this interface. You still give it a regular IP address, right, even though it's using that virtual IP. This IP address, R2's IP address, and the virtual IP all have to be within the subnet on these two routers. Make sense, guys? All right. No shut. Let's go in and do the same thing on router 2. Host name R2. Basic housekeeping. Interface gig 0/1. IP address 192.168.1.2. All right, guys. So we did our basics. So now this PC right here is actually a router. We're just gonna make it so that it acts like a PC. And guys, you could just come over here and do this and actually just make the PC, and it will also do DHCP. But I chose a router in case on my labs. Sometimes it's good to do debugs on them, right? Get a little bit more information. So no IP routing. Let's give this a host name just so we know it's the PC. And then we'll go into its interface and just do IP address DHCP. No shut. So another little extra in this configuration, what we're going to do is configure a DHCP pool on what should be our active Hsrp router. And you'll see how we configure that. The default gateway is the virtual IP we set up. So let's bring up R1, R2. And on R1, R2, we're also going to make a keychain. This keychain will be for the authentication of Hsrp. Hsrp, key 1, keystring Cisco. And no, we're not going to do any send or accept lifetimes. This is just a quick how to focus on Hsrp, right? Key 1, keystring Cisco. And of course, these keystrings have to match. All right, and now on R1, we're going to configure Hsrp and our DHCP pool. So we're going to go line by line in our Hsrp configuration. So the standby command is how we do any Hsrp configuration on our interface. The first one I'm going to do is set the version. We want to use version 2 so we can have authentication. And then that's just the standard now that we use in the industry, right? We always want to use the newer version, so we're going to do that. And then we're going to choose the priority. So we'll do 150. The default's 100. But let's actually look up Hsrp priority values and see if lower or greater is better. So the higher priority becomes the active router for Hsrp group. Let's actually take that off. And let's just configure it with no priority for now, and then see which one becomes our active router. So we are going to do standby 1, preempt, and this 1 right here is actually your Hsrp group, guys. So remember, we can have up to 4,095 groups in Hsrp. We're using group 1. So with that preempt command, right, if the standby router should go down, it'll become the active. And then once R1 comes back up, with this preemption command configured, it should then take over as the active router again, if it was the active router. And now standby 1's IP address. We'll just do .3. Remember, this has to be in the same subnet as these physical interfaces. And then we'll just do our authentication. It's really easy, guys. We'll set to MD5 instead of plain. And then we'll do our keychain. So you could just come here and just set a key string. I decided to use a keychain. Boom. And now if we do show standby, we can see some things. It's default priority. The authentication is using, preemption is enabled. It's saying we're the active router, but our standby is unknown. And that is because in R2 we haven't configured Hsrp yet. Before we go to router 2, let's configure our Dhcp pool. The network, obviously the network address of our routers here. But the default router is actually going to be our virtual IP address, because that is the gateway the users are going to use, right? Because we're implementing Hsrp in this network. So now we can go to R2, and let's do some configuration for Hsrp, standby version 2, standby 1, we'll do authentication first, MD5, keychain, Hsrp, and then we're going to give it the IP address, and this has to be shared, right? Okay, now if we do some verification, so we should see this standby come up, and here we go, state speak into standby. So it went through our, let's get this out of here, so it went through our hello messages, right? The initial, the learn, the listen, and then standby to active. So there's an IP address conflict. Oh. So this one we're going to have to actually say that .2 cannot be used in our Dhcp pool because that's assigned to router 2. So we do that as IP Dhcp excluded address 192.168.1.2. Then we can go down here and do clear IP Dhcp bindings all with the asterisk. All right, now let's go back to Hsrp. So we do show standby now. It shows us who the standby router is. It shows its priority, and it shows our priority. But router 1 is actually active, and that's because it came up first, guys. So now let's go into router 1. Let's go into gig 00. Let's actually shut our interface. R2 is now active. Do show standby. It's unknown because it's down. So we see this took over. And with preemption, once this comes back online, R1, we should go back to the Hsrp active state. Give it a few seconds, guys. Swing to speak standby. Let's go in and change its priority. Maybe that's what we're missing. Standby 1 priority 150. We know higher is better. And now we're in the active state. So it looks like, let's look at our configuration here. Interface gig 00. That preemption does work. However, our priority needs to be higher if we want to take back over as the active state. All right, guys. Awesome. And now if we go to this PC, which is actually just our Cisco router, we can see that we have an IP address assigned. let's see if we can ping. We're good. We can ping that virtual IP address. So that's all I have, guys, for Hsrp. Stay tuned for some more advanced Hsrp, right? We're actually going to implement some IPSLA. We're going to do some applets, and we can actually do Boolean logic to actually kind of tune our Hsrp for quick redundancy. All right, guys. So thank you for viewing. And for everyone here at Hsrp Technologies, remember to keep learning every single day.